What if everything we know is only a tiny fraction of what's really out there? What if the universe is far stranger than we ever imagined? Invisible waves, cosmic explosions, gigantic structures larger than entire galaxy clusters, and enormous regions of almost perfect emptiness. Tonight, we explore the dark universe. What if, somewhere in the universe, an explosion happened so powerful that for a few seconds it released more energy than our sun will produce during its entire 10 billion year lifetime? This isn't science fiction, it's real. It's called a gamma-ray burst, the most powerful explosion in the universe since the Big Bang itself. For a few brief moments, a single event can outshine entire galaxies, and yet, most people have never heard of them. These cosmic monsters happen in distant galaxies, billions of light years away. Thankfully, because if one occurred too close to Earth, the consequences could be catastrophic. But how do they form? There are two ways. The first begins with a giant star, a hypergiant, a star more than 30 times the mass of our sun. After millions of years, it runs out of fuel. Gravity takes over, its core collapses, and a black hole is born. But instead of a simple explosion, something extraordinary happens. Two incredibly narrow jets erupt from the poles, blasting outward at nearly the speed of light. And if one of those jets points directly at Earth, we detect a gamma-ray burst. These are known as long-duration bursts. They can last from a few seconds to several minutes. But there's another type, even more mysterious. Short-duration bursts. Some last less than a single second. These occur when two dead stars collide, two neutron stars, or sometimes a neutron star and a black hole. After orbiting each other for millions of years, they finally merge, releasing unimaginable energy and creating another black hole. But these collisions do something else, something extraordinary. They create gold, platinum, and uranium. Some of the rarest elements on Earth were forged during these violent cosmic collisions. The jewelry we wear today may have originated from stars that died billions of years ago. And even after the explosion ends, the story isn't over. A fading afterglow remains. X-rays, visible light, radio waves, echoes, traveling through the universe, allowing astronomers to study these ancient events. So here's the question. If some of the most valuable elements on Earth were created during the most violent explosions in the universe, how much of our world was born from cosmic destruction? What if the universe is making sounds right now? Not sounds you could hear with your ears, but vibrations traveling across the cosmos, ripples moving through space itself. They're called gravitational waves, and over 100 years ago, Albert Einstein predicted they should exist. In 1916, he proposed something extraordinary. Gravity isn't an invisible force pulling objects together. Instead, massive objects bend space and time itself. Imagine dropping a bowling ball onto a stretched sheet. The surface bends. Now imagine those massive objects moving, accelerating, colliding. When they do, they send ripples through space-time, just like waves spreading across water. These waves travel at the speed of light, across billions of light years, carrying information about the most violent events in the universe. The biggest sources are collisions, black holes, neutron stars, cosmic giants, spiraling toward each other, until eventually they merge, releasing enormous amounts of energy. But here's the unbelievable part. By the time these waves reach Earth, they are incredibly small. So small, they stretch and squeeze space by a distance thousands of times smaller than a single proton. Imagine trying to measure something smaller than an atom. That's why scientists built LIGO, one of the most sensitive instruments ever created, and in 2015, humanity detected gravitational waves for the very first time. For the first time in history, we didn't just see the universe, we heard it. Scientists converted the signal into sound, a tiny cosmic chirp, the final moments of two black holes colliding more than 1 billion light-years away. Before this discovery, we could only study the universe through light. Now, we have an entirely new sense. We can detect events that emit no light at all. Invisible black holes, dark collisions, hidden parts of reality that were once impossible to observe. And perhaps this is only the beginning, because every gravitational wave is a message, a whisper from the distant universe, traveling across space and time until finally it reaches us. So, here's the question. If the universe has been speaking for billions of years, what else have we not heard yet? What if the entire universe is connected, not metaphorically, literally? What if every galaxy, including our own, is part of a giant cosmic network, stretching across unimaginable distances? This is called the cosmic web, the largest structure ever discovered, and its giant strands are known as cosmic filaments. Immense thread-like structures stretching for hundreds of millions and sometimes billions of light-years. These aren't made of stars alone. In fact, stars are only a tiny part of the story. Most of the structure is invisible, built upon a hidden skeleton of dark matter, the mysterious substance that makes up most of the universe's mass. Dark matter pulls everything together, acting like an invisible framework, holding the universe in place. Along these enormous strands flows ordinary matter, hydrogen gas, plasma, the raw ingredients needed to create stars. Entire galaxies gather here, thousands, millions, traveling along these cosmic highways, and wherever these giant filaments intersect, something extraordinary happens. Galaxy clusters form, some of the largest collections of galaxies in existence. But here's where things become even stranger. These structures don't exist alone. They are connected, interwoven, stretching across the cosmos, like a gigantic three-dimensional spider web. Between them are enormous empty regions, cosmic voids, areas so vast they can span billions of light-years, almost completely empty. Imagine a universe where everything you know exists only along a giant network, and everything in between is mostly nothing. Yet, the universe is not standing still. Matter is constantly moving, pulled along these filaments, feeding growing galaxy clusters, like rivers flowing into giant oceans. And scientists recently discovered something unexpected. These gigantic structures can rotate, entire strands of galaxies, slowly spinning through space, and as they rotate, they can influence the spin of the galaxies inside them. Think about that. Structures larger than anything humans can imagine, moving together as one connected system. For decades, we couldn't even see them, because most of their material is either invisible dark matter or extremely faint gas. But today, powerful observatories like Hubble and the Very Large Telescope allow scientists to capture the glowing bridges of gas that connect distant galaxies. For the first time, we are beginning to see the true architecture of the universe. And then there are the giants. Some cosmic filaments stretch for billions of light-years. One of the largest structures ever discovered, the Hercules Corona Borealis Great Wall, is so enormous that light itself would take billions of years to cross it. A scale almost impossible for the human brain to comprehend, and perhaps that's the most fascinating part. The universe isn't random. It has structure, patterns, connections, an invisible design. stretching farther than we can truly imagine. So here's the question. If every galaxy is connected, what else might the universe be hiding? What is the emptiest place in the universe? Not deep space, not between stars. Something much bigger, something almost impossible to imagine. These are called cosmic voids, gigantic regions between the filaments of the cosmic web, immense dark expanses stretching across hundreds of millions of light years. At first glance, they appear empty, but they aren't, not entirely. In fact, cosmic voids are some of the most mysterious places in existence. To understand them, we have to go back to the beginning. After the Big Bang, matter wasn't distributed perfectly. Some regions contained slightly more material, others slightly less. Over billions of years, gravity pulled matter together, creating galaxies, galaxy clusters, and enormous cosmic filaments. But as matter flowed outward, something else was left behind. Vast, underdense regions, cosmic voids, the spaces between everything else. Imagine a giant three-dimensional spider web. The threads are galaxies, the intersections are galaxy clusters, and everything in between is mostly empty. These voids are enormous. Some span tens of millions of light years, others hundreds of millions, making them some of the largest structures in the observable universe. But here's where things become strange. They're not truly empty. Inside them, you'll still find traces of hydrogen, tiny amounts of dark matter, cosmic neutrinos, and something even more mysterious, dark energy. The force believed to be driving the expansion of the universe itself. In fact, inside these enormous, empty regions, dark energy may dominate, stretching space-time and pushing galaxies farther apart. Every second, every minute, every year, the universe continues to grow, and these voids continue to expand. But perhaps the most famous example is the Bootes Void, located roughly 700 million light-years away. This gigantic region spans nearly 200 million light-years across. To understand its scale, imagine this. A normal region of the universe, that size, should contain around 2,000 galaxies. The Bootes Void contains only 60 in a region so vast one that light itself would need 200 million years to cross it. Think about that. An emptiness larger than anything our minds were built to comprehend. And yet, it is a natural part of the universe. Perhaps that's what makes cosmic voids so fascinating, because they remind us that the universe is not full. It's mostly empty. Galaxies, stars, planets. Everything we know occupies only a tiny fraction of existence. The rest is darkness, silence, and unimaginable distances. So here's the question. If the largest structures in the universe are actually enormous regions of emptiness, how much of reality is nothing at all? Welcome to the dark universe.